This lesson concerns the slope of a line. The slope is always identified with the variable m. It also has another definition typically heard of as rise over run. What this rise means is the change in y, or the difference between the y values, which also can be described as y sub 2 minus y sub 1, divided by the run, which is the change in x just because of the horizontal motion, which also can be described by a difference of x sub 2 minus x sub 1. So when we're given two pair of points, we can determine what the slope is just merely by this formula of y sub 2 minus y sub 1 over x sub 2 minus x sub 1. But first of all, we need to identify the parts of the point. Each point is made up of an x and a y. And just because I'm looking at this point first, I'm going to call this point 1, which means I'm going to label it with the subscript 1. And because this is point 2, I'm going to label that with the subscript 2. So when we look at our formula of that, our slope is equal to the differences or the changes in y divided by the changes in x. When you look between 2 points on a line, we're going to use substitution. Y sub 2 is 11. Your formula has a minus sign. Y sub 1 is going to be positive 7 divided by x sub 2, which is actually negative 2, minus x sub 1, which is going to be positive 3. Now, when your signs are opposite, you subtract, which would give us a 4, and take the largest number sign, which would be positive. In the denominator, when your signs are the same, you actually add and take the sign. Well, the sign is negative, and then 2 plus 3 is going to give us 5. Now, we'll typically write that out to the side. So that would be negative 4/5 is the slope between the first point and the second point. We also need to identify slopes and y-intercepts of linear equations. The slope-intercept form of any line is written in the equation y equals to mx plus b. And when we write that equation down, that means if we could solve it for y, then we could easily select what our slope is, because that's what m is. So when I take this equation and I solve this for y, the first thing I need to do is move the negative 7 across the equal sign. So I'm going to add 7 to both sides. And there's not anything physically I can add it to on the right hand side. So I'm bring down my 2y equals to x plus 7. The reason I write my x first is because in slope-intercept form the x term is prior to your b, which happens to be your constant term. I still have to solve for 1y, so that means I need to divide everything by 2 individually. So when this occurs, my 2 cancels, and then I have y equals to, there is an understood 1 in front of that x, and there's a 2 in the denominator, so actually x's coefficient is 1/2. Plus 7 divided by 2, since it doesn't divide, I'm going to hang on to that fraction. So when I'm answering the question, what is my slope? My slope is going to equal to x's coefficient, which is positive 1/2. My y-intercept is actually where it crosses the y-axis at, is an ordered pair. It is a point. Now, for it to fall on the y-axis means that my x must be 0. And in this case right here, if I plug in a 0 for x, all I would be left with is this positive 7/2, which will always be your constant term for your y value for the y-intercept. Another thing we encounter when dealing with slopes are parallel and perpendicular lines. Parallel lines, which are also identified with this symbol right here, they always have the same slope because they never intersect. Perpendicular lines, which the symbol for perpendicular lines is like an upside down capital T, they have negative reciprocal slopes. That means you're going to flip it over and you're going to change the sign. So in this lesson we're determining, well, do we have parallel lines, perpendicular lines, and you may have lines that are neither parallel nor perpendicular. So we're given a set of lines here. Since the definition of these has so much to do with the slope, it would be good to identify the slope. But just like in the last example, to identify the slope, we need to be able to solve these equations for y. So I'm going to rewrite my first equation, 8x minus 11y equals to 15. And we're going to solve this for y. So that means we're going to move our 8x over by subtracting 8x from both sides. I have negative, the negative sign does come down, 11y equals to, I'm going to write my x term first and keep it in that same format as slope-intercept form. to solve for y, a positive 1y, I need to divide everything by negative 11, and I divide individually because sometimes they reduce differently. So I have negative 8 divided by negative 11. Well, it doesn't physically divide, but the negative divided by negative is a positive. And then 15 divided by negative 11, I'm just going to write it as negative 15 elevenths. What I'm looking for is my slope. So my slope out of this equation is positive 8 elevenths. So taking the second equation over here, 11x plus 8y equals to 1. And I'm going to solve it for y. So I'm going to subtract 11x or add a negative 11x to both sides. So I'm left with 8y equals to negative 11x plus 1. Divide everything by 8 because, again, you want a positive 1 in front of your y. So you're left with y equals to negative 11/8 x plus 1/8. And again, because I'm looking for parallel, perpendicular, neither, I'm only interested in the slope, which in this case is negative 11/8. So make sure that you actually answer the question. The question is asking, what type of lines are these? Well, they cannot be parallel because they're not exactly the same thing. But for perpendicular, they do match, that they have opposite signs. This is a positive, this is a negative, and that they are reciprocals of one another. Both of those things have to happen. So in this case, therefore, these are perpendicular lines according to their slopes. So you have perpendicular lines. You can either write it out or you can actually use the symbol.